Imagine a place where sunlight never reaches, and the crushing weight of the ice holds unimaginable secrets. Beneath the frozen silence of Antarctica, a hidden world lies submerged. What monstrous life lurks beneath the frozen surface? Are there silent hunters, perfectly adapted to the crushing cold and unimaginable darkness, with senses we can't even conceive of? Get ready to be shocked. Join us as we explore the most chilling truths under the frigid waters. Here are the new terrifying underwater discoveries in Antarctica, a world that chills us to the bone. Underground lakes. Far beneath the icy expanse of Antarctica lies a hidden world, a vast network of underground lakes, estimated more than 400 lakes, entombed for millions of years and entirely isolated from the surface. These lakes are believed to be remnants of a time when Antarctica was part of the supercontinent Gondwanaland, which broke apart over 180 million years ago. Lake Vostok, the largest of these subglacial lakes, has been encased in ice for a staggering 15 million years. They're super cold, way below freezing, and completely dark since no sunlight reaches them. Despite the perpetual darkness, a groundbreaking discovery in 2013 at Lake Whillans shattered expectations. Entire ecosystems, teeming with microscopic life forms adapted to these extreme conditions, have thrived for millions of years without ever seeing the sun. The possibilities are truly astounding. This network of lakes could be a vast, interconnected system with estuaries, rivers, and perhaps even hidden volcanoes spewing heat from the Earth's core. These hidden worlds could harbor unique life forms, unlike anything seen before, organisms that have evolved in isolation for ages. Rainforests and fossils. Forget freezing. Antarctica used to be a warm, green rainforest filled with plants and animals. Fossils hidden under the ice show this surprising past. Over 100 million years ago, it was part of a giant landmass with warm weather and rainforests. We know this because scientists have found fossils of trees and leaves buried under the ice. Fossil finds include marine animals, birds, and even dinosaurs from the Cretaceous period, hinting at a diverse ecosystem thriving in a bygone era. More recent discoveries, like fossils of beetles from 40 million years ago, add a new dimension to this engaging story. Singing ice. In the vast expanse of the Ross Ice Shelf in Antarctica, while it appears silent and still, a hidden symphony plays out beneath our feet. Strong winds whipping across the colossal snow dunes generate vibrations that translate into an eerie, melancholic song. These sounds are inaudible to the human ear. Scientists, however, have a way to listen in: seismic sensors. These instruments act as ultra-sensitive ears, picking up the vibrations coursing through the ice. The interesting part is that the ice shelf isn't singing the same tune all the time. The environment plays a crucial role in composing this melody. Changes in factors like wind speed, air temperature, and snow accumulation all influence the vibrations produced by the ice. This means that by studying the variations in the singing of the ice shelf, scientists can detect changes happening within the vast ice sheet and understand the impact of climate change on this critical part of Antarctica. A shift in the melody could indicate thinning ice, the formation of cracks, or increased stress on the ice shelf. Ice holes. Imagine a gap the size of Ireland opening up in the ice. That's what happened with the colossal Polonia hole. These icy chasms, scientifically called cryoconite holes, form due to a delicate interplay of sunlight and ocean currents. Deeper parts of the Southern Ocean hold comparatively warmer and saltier water. When specific oceanic conditions arise, these warmer currents can rise closer to the ice shelf. Dust and wind-blown debris settle on the surface of the ice sheet. These dark particles, known as cryoconite, absorb sunlight much more efficiently than the surrounding ice. This increased heat absorption triggers melting of the ice directly beneath the cryoconite. As melting progresses, a cavity begins to form. Over time, the hole can grow significantly, depending on factors like the size of the cryoconite patch and the duration of sunlight exposure. The appearance of these massive holes raises concerns about the impact of climate change on Antarctica. Increased ocean temperatures could lead to more frequent and larger cryoconite holes, accelerating ice loss from the continent. Mount Erebus. Mount Erebus, Antarctica's fiery giant, is one of the world's most active volcanoes. Over the past 30 years, volcanic activity has increased, with the volcano spewing forth molten magma and boasting ancient lava lakes that have been bubbling away for a staggering 1.3 million years. But this land of fire and ice is more than just a fiery giant. The extreme environment has fostered the development of unique life forms. Scientists have discovered organisms thriving within the volcano's heat and ice caves. These microorganisms that have adapted to survive in harsh conditions are a remarkable testament to the tenacity of life. Their presence adds to the wonder of this place, making Mount Erebus one of the most unique discoveries in the Antarctic region. World's oldest pyramids. In 2013, satellite imagery revealed a mysterious formation protruding from the ice in Antarctica, resembling a man-made pyramid. This discovery captured the imagination of many, as the Antarctic pyramid appeared to surpass the size of the Great Pyramid of Egypt. However, scientists have faced challenges in reaching the site due to the harsh Antarctic environment and the thick layers of ice covering the area. This lack of direct access has left the nature of the formation open to speculation, with some suggesting the possibility of ancient human ancestors being responsible for its construction. The existence of the Antarctic pyramid raises intriguing questions about the history of human civilization and the potential for ancient cultures to have reached the icy continent in the distant past. Ancient meteorites. Antarctica has become a hotspot for the collection of meteorites due to the continent's unique environmental conditions. The cold and dry climate acts as a natural freezer, preserving rocky fragments from meteorite showers that have bombarded the region over the years. The abundance of meteorites in Antarctica has led some researchers to speculate about the possibility of past alien life in the region. The sheer number of meteorites discovered, numbering more than 20,000 samples, suggests a long history of cosmic activity in Antarctica. The third man factor. Sir Ernest Shackleton, a legendary explorer, reported feeling the presence of a third man alongside him and his two companions during his harrowing expedition across Antarctica. Other explorers also have shared similar experiences. They describe a feeling of being accompanied by an unseen third person during moments of hardship and isolation. This presence can be described as comforting, supportive, or even guiding. The third man factor taps into our innate curiosity about the unexplained. It raises questions about perception, consciousness, and the potential existence of unseen forces in extreme environments. The phenomenon itself serves as a reminder of the mysteries that still surround us, even in the age of science. Blood falls. In the McMurdo Dry Valleys of Antarctica, there exists a fascinating natural wonder known as blood falls. This crimson-colored waterfall gets its name from its striking resemblance to flowing blood. Blood Falls is fed by a subglacial lake beneath the Taylor Glacier. The water in this lake is exceptionally salty and rich in iron. As the water flows beneath the glacier, it interacts with the underlying bedrock, which is rich in iron minerals. When this iron-rich water comes into contact with the air at the surface, it oxidizes. This reaction causes the water to turn a deep red color, similar to rust. The water in Blood Falls is so salty and mineral-rich that it remains liquid even in the freezing temperatures of Antarctica. This allows the waterfall to flow year-round. Scientists study the microbial life found in the subglacial lake to understand how life can exist in extreme environments, providing insights into the potential for life on other icy worlds in our solar system. Antarctic fungi. Antarctica is home to special fungi species that have adapted to the continent's extreme cold and dryness. These are called endemic species, meaning they're found nowhere else on Earth. Some of these Antarctic fungi have a surprising talent. They can break down hydrocarbons, which are the main components of oil. This includes materials like wood, and even the plastic of old petroleum containers left behind in research stations. Scientists are studying these oil-munching Antarctic fungi to see if their abilities can be harnessed for bioremediation. This means using natural organisms like fungi to clean up oil spills in a more eco-friendly way compared to traditional methods. A key advantage of these Antarctic fungi is their ability to function in frigid environments. This makes them potentially useful for cleaning up oil spills in cold regions, where traditional methods might be less effective. These grotesque creatures, unlike anything ever seen before, raise more questions than answers. How have they adapted to survive such unimaginable conditions? Are they the only ones lurking beneath the ice? And most chillingly, could something even more terrifying be waiting in the unseen abyss? The hunt for answers and the fear of what we might find has just begun.